Unit 2B is the next notes that we'll be taking, and we're going to continue on from what we did in 2A and just extend it to other conversions and analysis that we have. All right, for some basic background, the U.S. customary system. The U.S. customary system has roots dating back thousands of years, and its units became standard in often surprising ways. For example, a modern length of 1 yard was defined by English King Henry, who was in the 1100s to 1135, who decreed it was to be the distance from the tip of his nose to the tip of his thumb on his outstretched arm. So that would be a yard. The table in your text summarizes the official U.S. customary system, showing you standard units for length, weight, and volume. Let's do an example. The Kentucky Derby. The length of a Kentucky Derby horse race is 10 furlongs. How long is the race in miles? Now, you don't even have to know what furlongs are, but you do have to know how many furlongs are in a mile or how many miles are in a furlong, because we're converting from furlongs to miles. So there's a table in the textbook that you have, and you have textbook availability through MyLabs Plus, your e-text. 1 furlong equals 1/8 of a mile. This would be really good to have in your notes, so if you have in your homework or on your test, you can have that conversion ready, which is the same, 1/8 is the same as 0.125. So this is 1 furlong equals 0.125 miles. We can write the conversion factor in 2 other equivalent forms. For example, you can write 1 furlong equals 0.125 miles. That's supposed to be, I have an I there, I think that's a typo. Or you can revert it and say there's 1.25 miles in 1 furlong. All right, so depending on which one we're trying to cancel out and we're converting from and to, that is how you would set up your little fraction here. So always start with what is given. We've got 10 furlongs times, and since we want to get rid of furlongs, we're going to put that on the bottom. 1 furlong equals 0.125 miles. So you're going to multiply across, and you get 10 furlongs equal 1.25 miles. So it's 1 1/4 mile. The Kentucky Derby is a race of 1 1/4 mile that the horses run. All right, another example, let's do some price comparison. You're planning on making pesto and need to buy basil. At the grocery store, you can buy small containers of basil that's priced at $2.99 for each, which is 2/3 ounce container. At the farmer's market, you can buy basil in bunches for $12 per pound, which is the better deal. The first thing here is you have to have them in the same units so you understand what you're paying per unit in exactly each one. The first one at the supermarket is in ounces. The one at the farmer's market is in pounds. So we're going to have to convert to find the one we want between them. We need to know and both in the same units here, like I said, to compare your prices. Convert the small container price to the price per pound. So they're telling you here is you want to change this in ounces to how many you're paying per pound. Because you're paying $12 per pound at the farmer's market, we want to convert here and see how much you would be paying per pound at the grocery store. All right, so let's just organize our information. It's $2.99 per 2/3 ounce, which means we have to divide. Then we're going to multiply by the conversion. If you look in the chart in your book or on the paper that I gave you, there are 16 ounces per pound. So we're going to have to convert from the ounces to pound. So here we got $2.99 divided by 2/3 ounce. You can actually change this if you want to decimal. You don't have to have a fraction if that confuses you. So we're going to multiply that. Because we're trying to get rid of ounces and ounces are on the bottom, we're going to put 16 ounces per pound. So ounces will cancel and you're left per pound on the bottom. So in the grocery store, you would be paying $71.76 per pound instead of paying the $12 per pound at the farmer's market. So the small containers are priced at almost $72 per pound, which is 6 times as much as the farmer's market price, which was $12 per pound. All right, your metric system. The International Metric System was invented in France in the late 18th century for two primary reasons. One, to replace many customary units with just a few basic units. They wanted to get everything organized and condensed. And the second thing is to simplify conversions through use of a decimal, which is a base 10 system, like our system is, we count in tens. The basic unit of length, mass, time, volume, and metric system are these. For meter is for length, and it's abbreviated with an M. Kilogram is for mass, and it's abbreviated with kg. Seconds is for time, and it's abbreviated with S. And liter is for volume, it's abbreviated with a capital L. And these are our units for the metric system that they use. All right, these are great tables that you probably have to put in your notes. It would be great to have them readily available and organized. And it goes from the deci system, the deci, centi, milli, micro, nano, pico, and then it goes deca, hecto, kilo, mega, giga, and tera. Notice these are the smaller values. So a deci, say a decimeter, is less than a meter because they're small. All of these are less than one, whatever unit you have. A decigram will be less than a gram. That is why it is 1/10. It is to the -1. A deca is our larger ones. So if you had a decagram, it would be 10 times how many grams that you normally would have. Micro is usually abbreviated with a mu right here. That's a Greek letter mu. But in medical fields, it's also seen as MC instead. And again, that's a typo there. I apologize. They forgot the S in it instead. So let's do a metric conversion. So we're going to use metric prefixes. Convert 2,759 centimeters to meters. So the table shows that centi means 10 to the -2. So it's going to be, centimeters are smaller than meters. So that means 1 centimeter equals 10 to the -2 meters. Or you can turn that around and say that 1 meter equals 100 centimeters. Therefore, if we have 2,759 centimeters, it is the same as 27.59 meters, because you always start with what's given, 2,759 centimeters. We're going to use this one right here because it doesn't have exponents that we have to use. So since we're canceling centimeters, centimeters are on the bottom. 100 centimeters is equal to 1 meter. The centimeters will cancel. Oops. The centimeters will cancel, and you will take 2,759 and divide it by 100, and that's where you get your 27.59 meters. All right, let's talk about a marathon distance. A marathon running race is about 26.2 miles. How far is that in kilometers? So we're wanting to convert miles to kilometers. The table shows that 1 mile equals 1.6093 kilometers. We use the conversion in the form with miles in the denominator to find what it is in kilometers. So if we're going to start off, always start off with what's given, 26.2 miles. The miles have to be on the bottom because that's what we're canceling to make sure it's left to be in kilometers. So we'll cancel out miles and we multiply straight across. So a marathon is 42.2 kilometers. All right, temperature units. A lot of you are very familiar with Fahrenheit and Celsius. When you get into measuring stuff in chemistry, you'll also realize there's another unit called Kelvin. The Fahrenheit scale, commonly used in the United States, is defined so that water freezes at 32 degrees and it boils at 212 in Fahrenheit. Notice that they have the little degree symbol and the Fahrenheit, the F is there. The rest of the world uses Celsius scale, which places the freezing point of water at 0 degrees Celsius and the boiling point at 100 degrees Celsius, making sure that you see the difference in those right there. In science, we use Kelvin scale, which is the same as the Celsius scale except for its 0 point, which corresponds with negative 273.15 Celsius. So that right there would be your 0 point starting with Kelvin. So 0 Kelvin equals negative 273.15. A temperature of 0 K is known as absolute zero. Make sure you put this in your notes because it is the coldest possible temperature. The degree symbol, which is that little circle that we usually have, is not used in the Kelvin scale. So it's no degrees. It will just be your whatever you find it to be, the temperature to be, and you put a K beside of it. All right, to give you a visual, this is in Fahrenheit, this is in Celsius, and this is in Kelvin. So this is your absolute zero in Kelvin. That means when it is 0 Kelvin, it is negative 273.15 Celsius, but it is negative 459.67 Fahrenheit. Right here, when the water freezes, this is your freezing point. In kelvins, it's 273.15 kelvins. The freezing point in Celsius is 0. And the freezing point in Fahrenheit is 32. So these right here would be your conversion factors because they're equivalent at the freezing point. This is your boiling point. In kelvins, your water will boil at 373.15 kelvins. In Celsius, it will boil at 100 degrees Celsius. And in Fahrenheit, it boils at 212 degrees. So make sure you see these equivalents so if you need to change from one or the other on that one. They also have formulas that you can use with your Celsius, Fahrenheit, and Kelvin. This is the C stands for Celsius, the F stands for Fahrenheit, and the K stands for Kelvin. That's what it means respectively. These are in the order that these are also written. So in order to convert Celsius to Fahrenheit, they want you to multiply 1.8, or that's the equivalent of 9/5 fraction, and then add 32. So if you would write this in your notes, and you know that you're given Celsius and you're converting to Fahrenheit, this would be your formula. Fahrenheit would equal 1.8, the degrees in the Celsius, plus 32 degrees. If you're going Fahrenheit to Celsius, you're going to subtract 32 and then divide by 1.08. So this is the formula for that one. So if you're trying to figure out Celsius and it gives you Fahrenheit, you're going to hit C equals the degrees given in Fahrenheit minus 32 and then divide by 1.8, and that will put it in Celsius. Celsius to Kelvin, you only add 273.15. This would be your formula. Kelvin to Celsius, you're going to subtract 273.15. Okay? These formulas are just for your temperature conversions, but they're very helpful since there's 3 different temperatures that we are in. All right. So we're going to talk about human body temperature. Average human body temperature is 98.6 degrees Fahrenheit. They want to know what it is in Celsius and in Kelvin. So you're going to get 2 different answers here. You're actually going to convert Fahrenheit to Celsius, and then you're going to convert Fahrenheit to Kelvin, or you can convert what you had in Celsius to Kelvin, whichever is easier for you. Convert from Fahrenheit to Celsius by subtracting 32 and then dividing by 1.8. Remember the formula. Celsius equals Fahrenheit minus 32 divided by 1.8. The Fahrenheit that was given is 98.6, so I plug that in. Subtract 32, I get 66.6. Then I divide by 1.8. So the body temperature is 37.0 degrees Celsius. We can find the Kelvin by adding the 273.15 because converting from Celsius to Kelvin, you just add 273.15. So Kelvin equals Celsius plus 273.15. So we're going to plug in what we found here for Celsius, 37. So our Kelvin body temperature is 310.15 Kelvin. So you have 2 answers here, and there's your body temperature in Celsius, there's your body temperature in Kelvin. Units of energy and power. Energy is what makes matter move or heat up. The international metric unit is called a joule. Power is the rate at which the energy is used. The international metric unit is called watt. 1 watt equals 1 joule per second. Okay, a kilowatt hour is a unit of energy. 1 kilowatt hour equals 3.9 million joules. See the dash here? We're not doing a division, we're doing a multiplication here. So it's kilowatt hours, and that is 3.6 million joules. So let's do an example. Operating the cost of a light bulb. A utility company charges 15 cents per kilowatt hour of electricity. How much does it cost to keep a 100-watt light bulb on for a week? How much will you save in a year if you replace that bulb with an LED bulb that provides the same amount of light for only 25 watts of power? All right, so they're asking multiple questions here. So let's do it one at a time. All right, if you'll go back up here, given the first question they ask is how much does it cost to keep a 100-watt light bulb on for a week? So we got a 100-watt light bulb. You have to change them into kilowatts. Remember kilo, we have to put that in there. That would be 1 kilo is 1,000 watts. So that would cancel watts. Then we're going to say for a week. So you're going to multiply it times a week. Well, a week is 7 days per week. And then you have to do it per hour because it's kilowatt hours. And since we're canceling days, it's 24 hours in a day. So your watts canceled, your weeks canceled, and your days canceled. So I'm going to take 100. I'm going to divide it by 1,000. I'm going to multiply it by 7 and multiply it by 24. So how much does it cost to keep a 100-watt light bulb on for a week? First of all, it is 16.8 kilowatt hours. And then you go back up here and they charge 15 cents per kilowatt hour. Because remember, they want to know how much it costs, not how much you use. So now we're going to take what we found, 16.8 kilowatt hours, and multiply it by 15 cents per kilowatt hour. Now remember, this is cents when you multiply it. So you get 252 cents on that. So if this is in cents, when we change it to dollars, it's $2.52. Okay, be very careful with your answer. It would make sense that it would be $252. All right, so the electricity for the bulb costs $2.52 per week. If you replace the 100-watt bulb with a 25-watt LED, you will only use a fourth of that energy. They get that because 25 is a fourth of 100, which means your cost will only be a fourth of that. So if you take this and divide it by 4, it will be 63 cents. So they want to know what you're saving. So you have to find the difference between those two costs. So it's the wording in that in they say. So in other words, your savings will be, instead of spending $2.52, you're going to subtract the 63. If you use the 25-watt LED, you would save $1.89 per week. So in a year, how many weeks are in a year? There are 52 weeks in a year. So we are spending $1.89 per week. We want weeks to cancel, so we're going to put 52 down here. So you're going to multiply this across. So you're going to approximately save about $98 per year if you change from a 100-watt bulb to a 25-watt LED. Units of density and concentration. Density describes how compact or crowding something is. Material density is given in units of mass per unit volume. Example, grams per cubic centimeter. So how many grams are in a cubic centimeter? Population density is given the number of people per unit area. So that would be people per square mile. That's why it's written like this. So that would be the density population. Information density is given in units of mass per unit volume, like gigabytes per square inch. Concentration describes the amount of one substance mixed with another. The concentration of air pollutant is often measured by the number of molecules of the pollutant per million molecules of air. That's why they usually say ppms, because it's parts per million when they're talking about air pollution. Blood alcohol content, BAC, describes the concentration of alcohol in a person's body. Example, grams of alcohol per 100 milliliters of blood. So let's do an example. Medication dosage. A child weighing 15 kilograms has a bacterial ear infection. A physician orders treatment with amoxicillin as a dosage based on 30 milligrams per kilogram of body weight per day, divided into doses every 12 hours. All right, so there's a lot of information on here. And this is very important because this is why you make sure the dosage is right for a child so they don't get too much medicine and get poisoned. All right, so there are two questions with all that information up there. First of all, I would write that the child weighs 15 kilograms. Then I would write that your treatment is 30 milligrams per kilogram of body weight. Then per day, and it's divided into every 12 hours. Okay, so A, how much amoxicillin should the child be prescribed every 12 hours? B, if the medicine is to be taken in a liquid suspension with concentration of 25 milligrams per milliliter, how much should the child take every 12 hours? So the first A is asking the information at the top, and then they're asking you to do another conversion for B. All right, so let's just look at A. How much amoxicillin should the child be prescribed every 12 hours? The prescription doses is 30 milligrams per kilogram of body weight per day. But because it is given in 2 doses, that's every 12 hours, each dose will be based on half the total. Because there's 2 12 hours in every day, there's 24 hours in a day. Or then we would split this right here, that would become 15 milligrams of kilogram of body weight. Therefore, the child weighing 15 kilograms, the dosage should be, so in 12 hours, we just said that's going to be 15 milligrams per kilogram. You have to multiply it times how much the body weight is on the kid. So we multiply. Notice the kilograms go away. So this is giving us the dosage of the medicine in milligrams. So I get 225 milligrams, and that's every 12 hours. B, if the medicine is to be taken as a liquid suspension, the concentration 25 milligrams per milliliter, how much should they take every 12 hours? All right. So what they're actually wanting you to do is, they get 25 milligrams, you know that the kid is going to get 225 milligrams. They actually want to know what that measures in milliliters. So a liquid suspension contains 25 milligrams of amoxicillin per milliliter of liquid. And from part A, we already know that the total amount of amoxicillin in each dose should be 225 milligrams. That's every 12 hours, each dose. We are looking for the total amount of liquid that the child should be given for each dose, so the answer should have the units of milliliters. So here we're going to take what's given, what we found in A, 225 milligrams. Up here, they told us 25 milligrams per milliliter. So we're going to divide that. Right here, if you would remember, when you divide by a fraction, they just add an extra step here, and I know it's probably confusing because we'd already said if you're going to do milligrams and you need to cancel them, you want to put that on the bottom. But they did it first as division. So remember your keep, change, flip. So we keep the first number, and then we change it to multiplication, and then we flip this one. That's how they did that one. I don't know why they changed it from what we were doing earlier. But you cancel out milligrams. Remember, we're wanting it in milliliters. So it would be 225 divided by 25, and you get approximately 9 milliliters per dose. So that means 225 milligrams is the same as 9 milliliters.